cool. Yay. Okay. So, hello, everyone. Thank you so much for joining us this evening. We are the Pittsburgh Java user group. You already know where to get our notifications and our upcoming events information. It's the Pittsburgh Java Meetup group. We also try to be active on the X platform, Twitter, formerly known as Twitter. We try to share some news about like what's happening in the Java space. But then, yeah, if you want to learn more about our upcoming events, please do, follow us on the Meetup group. All our recordings are up on YouTube channel, so you should see everything from, I don't know, I think 2021. I think it's all up there. We do take a couple of weeks to put them up there, but eventually you will find the new recordings. So the last one from Chandra on Apache Maven 4 is up already on our channel, so go check that out. And then this one will also be up on our YouTube channel shortly after the session. And we like to thank our official sponsor, BNY. And with that, I want to hand it off to Dan. Dan, I'll just let you introduce yourself. Honestly, I don't think you need any introduction, but sure, go for it. I will stop sharing and then you can take control.
All right, I really appreciate it. I appreciate you guys having me here. Like I said, hopefully one day I can get out to Pittsburgh and see all of you guys in person. But this is the next best thing, and we get to talk about something I'm passionate about today, which is Spring AI. So this is really about building intelligent applications in Java with Spring AI. My name is Dan Vega. I'm a Spring developer advocate at Broadcom. A little bit about me. You can find out more about me at danvega.dev. I'm a husband and a father. My beautiful wife, Jen, our two daughters, Isabella and Juliana. We live outside of Cleveland. Yes, our football teams hate each other, but other than that, there's no blood between these two cities. I love Pittsburgh. I love visiting Pittsburgh. I'm a big Pirates fan outside of the Guardians, so huge fan of Pittsburgh outside of football, of course. I was named a Java champion this year. That was super exciting. That was kind of a lifelong career goal of mine. Beyond blessed to have that bestowed upon me. I've been doing this a while, 23 years. I hate putting that number up there because I feel kind of old, but I guess I am old. So I've worn a lot of different hats in this industry. My favorite one is the one I'm wearing now, which is that of a Spring developer advocate. Because long before anyone was paying me to do so, I was an advocate of Java. I was an advocate of Spring. And one message I kind of like to give to everyone is that you do not need permission to advocate for the things that you're passionate about. I kind of like to leave that with people. You never know where it's going to lead. It's kind of led me to this point. So if there's something you're passionate about, go out and talk about it. Do a lunch and learn. Do a meetup. Volunteer to speak at a meetup group, this one in particular. And just go out and talk about the things you're passionate about. You can find me on the Bird app. I don't know what we're calling it these days. So at the real Dan Vega. And when I'm not doing this, I enjoy spending time with my family. I enjoy running. I enjoy golf. So that's a little bit about me. Something else I want to leave you with. There's a live stream that we do every Monday, 1 to 2, called Spring Office Hours. This is our chance to get you caught up with everything that's happening in the Spring ecosystem. If you can't catch the live stream, then you can catch the replay. But we do a lot of answering questions here. So if you have questions about anything kind of related to Spring, this is a really good forum to bring those questions to. If you missed the live stream or the replay, we turn this into a podcast. So you can get this wherever you get your podcasts, a free resource, Spring Office Hours. So a little bit what I want to cover today. I'm going to kind of go fast through some of the beginning stuff, but I do want to level set. We hear the term AI a lot, and it's like, okay, well, this is a very broad term. It encompasses a lot. It covers a lot of things. What do we care about when it comes to us as developers, when it comes to AI? So I want to focus in on that and just cover some terms so we all understand like what we're kind of dealing with. Once we level set, where does Java come into this? Because we hear AI all the time with like machine learning and deep learning and data science, and it really is kind of dominated by the Python space. So where does Java kind of fit into this? And then we'll talk about this project called Spring AI. And hopefully we'll do some live coding today, and we'll look at some examples, and I'll leave you with a repo that has a bunch of examples in it. So as I said, I think we can all agree that we're kind of inundated with AI these days, right? It's everywhere. You go on social media, you hear about it. You go on Product Hunt. Every product out there is now with AI. Your managers, people on your team might be coming to you saying, how can we take advantage of AI? But as I said, it's a pretty broad term. It's a broad discipline. And I want to kind of focus in on what is the AI that we're talking about today, things that were important to us as developers. So we have this kind of wide range of different techniques. I want to focus on just a subset of those today. So we start with machine learning. There is a subset of machine learning called deep learning, which is uses these things called neural networks, and we'll touch briefly on those later. When we get into deep learning, there's two sides of this. There's something called supervised learning, and this is an approach where a model is trained using labeled data sets. So in this context, every training example is associated with an output label. The aim of this is to establish a link between the inputs and the outputs, which can then be utilized to predict labels for new unseen data. So that's supervised learning. We take an input and we label it, and hopefully we do enough of that labeling and we can start to get an idea of new data without having to give it labels. We'll look at some examples of that. And then there's unsupervised learning. And this is a type of machine learning where the model is trained on data without labeled response. And so where that really comes in is the idea of large language models. And these large language models are trained on vast amounts of training data. And this is powered by a lot of compute power. So they use this thing called unsupervised or self-supervised learning during their training data. And they're able to predict the next word in a sentence or fill in the blanks or use context from surrounding text. And that's how we get to the idea of kind of generative AI. Generative AI is based on something called the transformer architecture. We'll dive into that a little bit. And it takes this training data and can generate something completely new, something that it didn't have in its training data. So at the intersection of this are tools that we're used to seeing now, things like OpenAI's GPT or Google Gemini or some of the other popular LLMs out there. Now, like many of the names in the field of AI, the term machine learning isn't very helpful, right? It doesn't really tell us a lot. It kind of suggests that we can just throw a machine in a room with a bunch of books and it kind of learns on its own, right? We know that's not really the case. So I think a really good place to start is just to learn a little bit more about machine learning and what it is. So I said this before with supervised learning, right? We use this training data. So we have a whole bunch of training data that we use to train a model. Then that trained model can make predictions based on data it's never seen before. And we'll take a look at a couple examples of this, of things that you're probably using today that you may not realize is machine learning. So the big one is facial recognition, right? If I give it enough pictures of me and I say, that is me, that is me, that is me, I should be able to give it a new image without telling it who's in that picture. And it should be able to recognize that, hey, I indeed see a picture of Dan in that image. So you do this all the time. If you go on like Facebook or Instagram and you tag yourself in a picture, or you tag your mom and your dad, eventually it's going to go, okay, I don't need you to tag me anymore because I've got enough data. I can kind of find that person in new images. You can recognize tumors on X-ray scans. So if we give it enough X-ray scans and say, this is a tumor, this is a tumor, this is not a tumor. I always use the Arnold Schwarzenegger voice in my head when I say it's not a tumor. And you do enough of that labeling, then you can give it X-ray scans and say, what do you think this is? And it will be able to kind of classify that. Same thing with like abnormality on ultrasounds, say self-driving mode in cars. The way they do this is they're trained on lots of data, being able to say, this is a stop sign, this is a pedestrian. A really funny story I heard about this was, so you give it enough stop signs, right? Like the car now knows what a stop sign it is, and its response to that is to stop. I heard a story about a Tesla on the highway, kept stopping on the middle of the highway. And that's because there was a truck in front of this Tesla with a whole bunch of stop signs on the back of the truck. So again, this is where kind of like training the data and then like coming back and adding those little kind of unique situations in and fixing those comes into play. Fraud detection, your bank does this all the time. Hey, we've seen enough of these. We know what fraud looks like. We label these as fraud, and now we can pass it new transactions, and it can figure out if this is fraud or not. Things like product recommendations on YouTube, spam filtering, and more. Another really cool thing I heard about on a podcast is some NBA teams. I know of a couple that do this. I don't know if every team does this, but a whole bunch of players are in the gym, right? They're practicing. We know who's on the team, and we use facial recognition to find out like where you are in the gym. So I'm following Dan around the gym, and he goes to the free throw line, and I shoot 100 free throws. And I don't keep track of this because I'm just practicing, right? When I come in though, it was able to use facial recognition to watch me where I am on the court and said, oh, you shot 100 free throws and you made 95. Or you shot 23 3-pointers from the left side of the court and you made 10 of those. So just using those and then being able to like find, run reports on that, run analytics, stats on that. I just thought that was really cool to see. So again, back to supervised learning. We take a picture, we label it and say, that is Dan. Take another one, we take another one. We give it some type of image and don't put any label on this. It should be able to figure out that that's me now. And this is supervised learning. And this is, again, as I mentioned before, if you didn't already realize this, big data companies are asking you for help. And you are the ones that are labeling these data points for them. So when you tag someone on Facebook or you tag someone on Instagram, you are helping to train these big models of the big data companies. So, okay, machine learning at a high level. If you remember back to my diagram of machine learning, though, there's a subset of that called deep learning. Now, we're not going to get too technical with this because, quite frankly, I'm not an expert on this, but I do want to just talk about this at a high level. So if you look at a human brain or an animal brain, it contains enormous amounts of nerve cells called neurons. These nerve cells are connected to one another in a vast network called a neural network. The human brain has something like 86 billion of them. I mean, it's mind-blowing. It's pretty crazy, right? So what do we care about that when it comes to machine learning? How can we implement something like that in software? Right? Deep learning is a subset of machine learning, and it involves algorithms that model and mimic the structure and function of a human brain, known as artificial neural networks. Now, the idea of a computer network that looks like a human brain has been around since the 40s. It was really only this century, though, that it became possible because of really kind of three key things. We had some scientific advances in deep learning. We have the availability of big data. It turns out that you need a lot of data to configure these neural networks, data that we didn't have even 40 years ago, right? And then we need lots of compute power. You need to be able to compute to configure all of these different networks. And these were the ingredients that really started to make the AI that we're talking about today possible. It turns out a particular type of computer processor was really good at doing all of these mathematics to build these neural networks, and that was a GPU. So you need a lot of compute power. This was all kind of supercharged by the GPU. So the availability of big data combined with the compute power and the GPU is where we really start to see some of the technology that we're talking about today come into fruition. So where does that take us? It starts to become clear that bigger is better, more data, right? So we have these things called large language models. And around 2017, we saw a flurry of AI application. And what launched all of this was probably one of the most important papers on AI in the last decade. And it was called Attention is All You Need. Pay attention to the capitalization of attention and is AI, right? This came out of Google Brain. You'll see there's, 8 engineers there that worked on this at the research lab. All 8 of these engineers have since left Google and started their own companies. They're all brilliant minds. And what they kind of figured out is that you need very large neural networks. You need vast amounts of training data. We kind of knew that. Huge compute power to create this general purpose AI. And what made this possible was something that came out of this paper called a transformer architecture. And this was a specialized architecture for token prediction. Like, it's a novel way to look up words in a sentence, assigning weights to words. And this is really where the start, well, not the start, but really the innovation of generative AI came from. So it's not just a big neural networks. What are large language models? We hear the term, what the heck is it? It's not just a search tool. It is a text pattern recognizer and probabilistic text completion tool. Again, you teach it, you train it to recognize text patterns. You then ask it to complete the most probable text given a starting point, which is say like a prompt. Now, LMs are a type of artificial intelligence that can generate text, understand language, answer questions, and more. As we said, big data is a requirement here. They're large because they have vast numbers of parameters. When we say vast, what do we mean? ChatGPT has something like 175 billion parameters. It's trained on hundreds of billions of words. In other words, it's trained on the internet, right? We all know this. Most of the internet is being, this is what these large language models are being trained on. And that's why you see a lot of the big companies with more of some of the most popular LLMs, right? The OpenAIs who gets all this money thrown at them. Companies like Microsoft and Google. These are the big companies because it costs a lot of money to build these large language models. And then you also see like a lot of companies being sued over, hey, you can't include our content in your training data. Like the New York Times famously sued OpenAI and said, you can't include that, please pull that out. There's even ways to add some meta tags now to your website to say, hey, don't include this in training data. But that's going to be something that is interesting going forward, like what data is allowed for these large language models to be trained on. Now, they're not just large models. There are a whole bunch of large language models out there outside of the ones that you've probably heard of. I like this website, huggingface.io. If you go over to there and look at the models, you could see kind of like an index of all the models out there. When I took this, it looks like 571,000 models are out there. So the big ones are there, but if you want more niche models to work with, more specific models, some of them are even smaller. So if you want to run these models on your own machine, you can do that as well. This is a really good resource to check out. So now that we know that transformer architecture that came out of that paper, I want to kind of bring that back to the GPTs of the world, the Google Geminis. Like, what are they? And so GPT stands for Generative Pre-trained Transformer. Generative, hey, we're generating something new. Pre-trained, we understand that these models are pre-trained on tons of data. Transformer architecture that came from that paper. So that's where kind of GPT comes from. So what is generative AI? It's not just machine learning. It's not those things that we looked at before. Remember, supervised learning, we take something, we give it a label, we hopefully can classify something later on. Unlike that, AI can take the training data and generate something completely new. And so, yeah, maybe it's trained on books around the world, but based on that knowledge, now it can generate something completely new. It's not just kind of recalling something that it's been trained on. It's creating something completely new. So again, not generative AI, being able to create a number, a classification, a probability. Yes, this is a tumor. Yes, this is an abnormality on an ultrasound. That's not generative AI because we've given it enough training data so that I can make that kind of classification. What is generative AI is natural language, being able to respond to text or speech and then generate natural language, whether it's text or speech or images. We can create images from text. We can also look at images and figure out what's in that image. We could take audio and do some cool things with that. So that's my quick level set on some of the terms in AI and what does it mean to us. So now that we know that, I think an obvious question becomes, what's Java's role in AI? For the longest time, we've heard that the machine learning, the deep learning space was dominated by Python, and rightfully so. It had a great set of tools and frameworks for data science. But I think now that we've level set, right, we understand that there's one side of this equation, which is, hey, we have these large language models that need to get built. All this data, all this compute power, they need to be trained. Some of them are kind of refined and really kind of honed in. The other side of this is being able to take advantage or consume these large language models. And that's where we fit in here in Java. Now, there are certainly tools in this space to train data sets, train models, but what we're talking about today is being able to take advantage of some of these large language models. And that fits into Java real well. I kind of similar uh, one of the things I always talk about is, AI is becoming ubiquitous across the IT landscape. Java, we know, is the language of the enterprise. We probably have our bosses, our managers, somebody coming to us saying, how can we take advantage of AI in the products that we're kind of shipping, right? So one thing I liken this to is the same abstraction like Spring Data. We need to talk to a database. How can we do that? Spring Data is a project that gives us these level of abstractions to talk to any relational database or any like document store, right? It gives us this like abstraction level. And Spring AI is very similar. So it's going to give us an abstraction level to talk to the different LLMs that are out there. So what are some use cases for this within your organization? Maybe you have a bunch of documentation and you want to provide Q&A over those documentation. Maybe you have docs and you need to get summarizations of them or pull out key facts. Maybe you need to take what you have and generate something completely new, like text, code, images, audio. There's even video generation that's happening now that I'm really excited about. So we're going to talk about OpenAI today, but there's a lot of different LLMs out there. But OpenAI has a REST API. So if I wanted to use it, I don't need any programming language. I could drop down into curl, right? Here's a script. I'm making a curl out to the OpenAI's API endpoint. I'm giving it my OpenAPI key, passing that as an authorization header. I'm passing some JSON in to say, hey, this is the model I want to use. Here's my prompt. And if I go ahead and run that and everything works out, I get a response back. So you see, I get a lot of metadata around that response. In there, there's the content. That's the actual answer I care about. But I don't need any programming language to go ahead and take advantage of something like GPT. I can even do this in Java. So since JDK 11, there's a JDK HTTP client. Similar thing. I have my API key. I have my JSON. I create a request, send that off. I get a response back. So you could do this without any other projects, but the problem with this is when you start building real world applications, you're going to realize that there are a lot of common problems that you're going to need to solve for. And so Spring AI comes around and it's much more than just a facility for making REST API calls. So Spring AI, that's what we're here to talk about today. What is it? It is a new project. Its current version is 1.0.0 milestone 1. I think milestone 2 is coming up very shortly. You can learn more about it on spring.io. The lead for this is Mark Pollock. Dr. Pollock has often said the project was inspired by some projects in the Python space, right? LangChain and Llama Index are two of those projects that kind of inspired this. What it does for us, though, is a few things similar to something like Spring Data, right? It gives us that abstraction level. One thing that it does is provide portable chat completions, portable embedding clients for vector stores, regardless of whatever LLM that we're talking to. So we write the same code, we use a chat client, and it doesn't care which LLM we're talking to. So you don't need to go refactor your code if you change LLM providers. And I've heard that before in the Spring Data world, right? The first time I heard about Spring Data, I was like, okay, well, you can write code against a Postgres database. And if you go change your entire code base over to talk to an Oracle database, you don't need to change code. And while that was great, I haven't run across that a lot in my career where we've just switched out entire databases for an entire application. So while that was great, it's not something I had ever had to deal with. But with this, I've seen a lot of different scenarios where I'm writing some code against, say, OpenAI's GPT, and I want to test it against something else. I want to test it against Google Gemini or Anthropic's Claude 3.5 version of their LM. I can simply change out a starter. I can simply change a couple of configuration properties. And now I'm talking to another LM and I can kind of get an idea of like which one is working better for the use case that I'm on. So that's exciting. So the Spring AI API covers a wide range of functionalities. Being able to chat, right? The classic example, give it some text, get some text back. Text to image. Hey, I want to give you some text and create me an image based off of this description I just gave you. Transcriptions. One of the things I've been doing is taking that podcast and saying, here's the audio, give me some text back. Now I get the whole transcription of an hour-long podcast, and I can do some things with that. Now I can say, summarize that entire podcast for me in 2 to 3 sentences. I can also say, pull me out some key points. If we have a guest on, I could say, tell me a little bit more about that guest. If anytime we mentioned we are going to use this in the show notes, or we'll include this in the show notes, I can make sure I can pick those out. So you can do a lot of cool things with transcriptions. And then we'll talk about embeddings and functions and being able to kind of bring your own data to this. I'm going to skip past a couple of this because I just want to like show you how to get started with this and write some code, and we'll go through a bunch of examples. So we get started. Start that spring.io. We're going to pick out Spring Web because I'm going to create a REST controller so that can respond to requests that way. And then we just pick out the LLM that we're going to talk to. So we have support for a whole bunch of different LLMs. I would say check out the documentation if you want to learn more about which ones are supported, but you just pick out the one. In this case, I'm going to talk to OpenAI's GPT-4o today. So I pick that, and that's it. Those are the only dependencies I need. Now, the one requirement on this is that you do have an API key. So for this, we're using OpenAI. You can go out and get an API key from OpenAI, and then go ahead and use that. Now, I will say, there's just kind of as a caveat, you always want to make sure you understand that this does cost money in the real world. Like if we start using this in production, and the currency of LLMs all across the landscape is something called a token. And so if you look at pricing models for different LLMs, you'll go in there and you'll see, okay, it's the GPT-4 is $30 for 1 million tokens on the input, what I am sending to it. It's $60 for 1 million tokens being sent back to me. Now, I'll say I put $10 into my OpenAI account probably maybe a year ago, and I've used $1.50. So I'm using it just on a development machine. So if you're just doing development, I wouldn't worry too much about the pricing, but again, it's something you should be aware of, especially if we're going to production with this and we're doing high throughput, definitely something we need to think of. And there are different models. Different LMs have different models. Some are faster, some are more expensive, some are less expensive. And so if this is something that's going to go to production, that's definitely something that you want to take into account. Now, when we say tokens are the currency of LMs, is a token a word, a character? No. Some of these, like OpenAI, has this thing called a tokenizer. And you can basically put a chunk of text in there and it'll show you, based on that, what are tokens. So if you look down at below, you'll see like the color coding. Those are each of the tokens. So in here, 363 characters, roughly 78 tokens. If you were to do 1,000 words, I believe it is, you would roughly get 750 tokens. So it's something like that. But that's something to think of. So that is how it's priced out. Okay, we start our project. We've downloaded, we've opened up our web project with our OpenAI in it. How do we get started? So we need 2 things. First is that API key that we just created on OpenAI's website, and then the model. I said there are different models that you can choose from. I believe there might be a default for this, but I always I am very explicit with which model I'm using. In this one, I'm using GPT-4, but in the example we'll look at today, I'm using the newest one, which is GPT-4o. So those are the only things you need to get started. If you start your application up without setting those, it's going to throw an error and tell you, hey, you need, you included that Spring Boot starter, but you didn't configure OpenAI. So once those are configured, that's all you need. But there's also a lot of other properties that you can set check out the documentation forum. Like, for example, max tokens. We just talked about tokens, right? What if I didn't want someone to be able to stuff in 100,000 tokens because I'm paying for that, right? So you can set like a max tokens on the input and kind of control that there. So that's my spiel. Let's go ahead and take a look at this in some code. Cool. So I'm going to create a new project here. Let's go ahead and make this a little bigger. And I'm going to say, I'm going to use Java, Maven. I'm going to use the latest stable version of Spring Boot, which is 3.3.2. And I'll say dev.dan-vega. We'll call this the pjug. And again, we just need those two dependencies. I'm going to say web, and I'm going to say open AI, and that's it. So I'm going to go ahead and generate this. See if we can download this and open this up. All right, let me move that over here, and here's our application. So first thing I'm going to do is go into that and set those settings. So we need an API key. If you grab one from the website, you can come in here and just kind of hard code it in if you want. But beware of that. Again, we don't want to leak our credentials. We don't want to push this to GitHub. So I have an environment variable for this. So I have OpenAI API key. You just have to trust that it's there. And then I'm going to set the model. I'm going to say we're using GPT-4o. So again, that's all I need to get started. If I go ahead and start this, it should work. Yep. Okay, so no errors there. So we're off and running. So this is, I want to start and create our first kind of application that talks to GPT. So I'm going to create a chat controller, and this chat controller is going to be a REST controller. And I'm going to create a get mapping for slash. And what we want to do is we're just going to call this joke, and we're going to return a joke. We'll come back to this in a second. So remember back when I got started saying that part of this is giving us that abstraction level, right? We want to be able to talk to the different LLMs without writing LLM specific code. So the first part of that is in the chat world, give it some text, get a text response back, right? We have something called a chat. I can actually make this final. We have something called a chat client. So a chat client, let me just do this real quick. So a chat client is an interface, right? So we have this chat client interface. If we look at this, we have a default chat client here that we can get out of this builder. So this code should look pretty familiar if you've ever written something using like the web client or the REST client. This is a similar approach. What this allows us to do again is, because OpenAI is on the class path right now, we're using the OpenAI chat client. And then if we switch our properties over to use something like Google Gemini, we can use that. So now that I have an instance of the chat client, I can use it to talk to the LLM. So I can come in here and say chat client.prompt. I want to pass a message. So think about this as like if you went on ChatGPT's website, there's that input box where you want to type a message. This is where you can type that message, right? This is the user message that we're sending. There are some different roles or different types of messages. We'll see if we can't look at another example of that in a second. But here I just want to say, tell me a dad joke about dogs, because I love dad jokes. So that's the user message. Now we're just going to call. We're going to make a call out to the GPT-4o. And then it's, what do you want to get back from the response? In this case, I just want a string. So we can do that by saying return the content. So this is the entirety of me talking to the LLM. So what I want to do is rerun this application. I need a way to test this. So I want to call localhost 8080. I need some type of HTTP client. I could use something like Postman. I can use curl. I'm not a big fan of curl. I never remember all the parameters, the options. So I use something called HTTP IE. All we're doing here is making a GET request to localhost 8080. And with that, it should return back one thing you notice really quick, GPT 4.0 has surprised me. It's really much faster than GPT 4 and GPT 3.5 Turbo. I thoroughly enjoyed it. So we got a dad joke back. It says, "Why did the dog sit in the shade? Because he didn't want to be a hot dog." Good one. That one doesn't get old for me. I've seen it a lot, and I told to my daughter, and she took it to school, and everybody loved it. We even got some emojis back from that. Yeah, I see you popped in there. Do we have some questions?
To laugh out loud.
It was a good one. I like that
Yeah,
one.
it is a good one. Yeah.
All right. Now one thing here, we kind of hard coded this string in here, right? And this whole entire thing was hard coded in. What if we wanted to like substitute some parameters? So let's do another one. Jokes by topic. And we'll do something similar here. We're going to return a string, jokes by topic. And what we'll do is we'll take in a topic. So we'll say string topic. So now what I want to do is, again, return that chat client prompt. What is the user message? Now, if I type this in here, how can I substitute some type of parameters? Well, I really can't. This is just a string. But there is a version of this, if we look in here, that takes in something called a consumer. And a consumer is a functional interface. So if we look at this consumer, it is of type user spec, and there are some different things that we can do with this. This also implements something called the prompt spec, which we can pass in text, we can pass in params and kind of substitute those. So this tells me that I can do something like this. I can say u.text is tell me a joke. Actually, let me make sure it's a dad joke. Tell me a dad joke about, then I can say topic. So now I have a kind of a placeholder there. And then I can say, oops, dot param. And now I can say, go ahead and replace param topic with whatever we got as an argument, right? And then same thing, I'm just going to make a call and I just want to get a string back. So if we rerun this, all right, and then I come back over here and I say jokes by topic. And let's just say our topic is, we'll do cats now. And then, sure, here's a dad joke for you. Why was the cat sitting on the computer? Because it wanted to keep an eye on the mouse. Good one, good one. Okay, cool. So that is kind of the intro. Let's look at one more. Now, both of these, when we use this call method, this is going to be a blocking call. So we send out a request and we have to wait for the LM to generate the response and send the response back to us. What if there was a version where we didn't want to do that? What if we were asking it something a little bit more complex? No, I do not want to install an update during a presentation, IntelliJ. Come on. What if I didn't want it to be a blocking call? What if I wanted to start to get a response as soon as I got a response? Think of ChatGPT. When you go there and you type in a question, hey, I want to visit Pittsburgh. Give me 10 places in Pittsburgh that I must visit. It starts to like output that right away. It doesn't wait for the entire response to come back, right? So what if we wanted to do something like that? Let's do stream controller. We'll create a REST controller, and I'm going to create a get mapping called stream. And what we want to return here is not a string, right? What we want to return now is a flux of strings. And well, let's just call this with stream. Oops. With stream. So again, I want to get that chat client. So say private final chat client, get this through here. Yeah. And then now what I can do is say return, same thing, chat client.prompt, what is the message? What is the prompt that we're sending? In this case, I am visiting Pittsburgh. What are 10 places I must visit? Right. But now, instead of using that call method, which we know is now blocking, we can use the stream method. So now, yes, I just want that back as a string. So now, if I go ahead and restart this and go back to my terminal here, I can say 8080. Actually, let me do this. You have to just kind of, whatever tool you're using, curl, HTTPie, Postman, you got to tell it that this is, we're going to accept a stream back. So I'm going to say 8080/stream. And now you can see like we start to get those responses right away instead of waiting that entire time for that. So that's pretty cool. Okay, I think that's enough live coding because we could do this, but we only have an hour. So I've been doing this live coding, but I have some more examples I want to show since we don't have all night. We can't do a whole bunch of live coding. I do want to show some stuff off though. That repo, there's a repo, so Spring AI Workshop. This is at github.com/Dan Vega, Spring AI Workshop. There's a bunch of examples in there, and I want to just walk through a couple to show off some other examples. In fact, I do want to, actually, let's go here and just kind of talk about bringing your own data, because this is another important one. Oh, you know what? I do want to show something off first, and then we'll go back to that. So one of the examples that we just looked at, right? We just got a string back. We said, hey, call it and then give me the content, return it as a string. But that's not always the case, right? When we get into working with real world applications, a lot of the time when we get a response back, we're going to want a particular type. And fortunately, Spring AI gives us a really good way to kind of do this out of the box. So I have this output. I have a record here, and this record is called actor films. And it has two components. The first is an actor, which is of type string, and the next is movies, which is a list of strings. So what I want to do is, no matter what I call from the LLM, I want to say, this is how I want the output. Now, why does this become important? So let's look at an example of this and where this really comes into play. I want to, is my other one running? No, I want to go ahead and run this. And I want to take a look at this example where I'm just doing this normally, right? I'm just saying, hey, generate a filmography for Anthony Hopkins for the year 2010. Just return to me this a string. Like however you think you should return this, that's okay with me, right? So if I do that and I say films string, and we look at the response, it's going to have a bunch of stuff that I don't really care about, right? First off, it's like in a list format, 1 and 2. There's the stars, there's the Wolfman, here's the role, here's the synopsis. Like I didn't want all this stuff, but the LM didn't know that. Like we weren't very specific with what we wanted. In this next example, though, if you look at this, instead of calling .content, I'm calling .entity, and I'm giving it a specific type. So now that I've given it that type that has a string actor and a list of string movies, what happens behind the scenes is Spring AI basically creates like a JSON spec of this. And as it calls it, it says, here's the inquiry, generate a filmography for Anthony Hopkins. But I want you to return me JSON, and I want you to return it in this format, right? So same kind of question, but if we call this and just call films, now we should match that type as the response and just get the actor, which is Anthony Hopkins, and then a list of movies. Those are a list of strings. So this becomes very important because who knows what the LLM is going to send us as a response, right? So this really helps out in kind of getting the type. In another example, I'm doing the same thing, but I am doing a list of those. So I want a new parameterized type reference, which is a way to kind of give me a collection. And then this should return a list of actor films. So we already saw that record type. Now we can say, hey, for Denzel Washington, Leonardo DiCaprio, and Tom Hanks, generate that filmography for me. So films list. And again, it should now match up with that record type that we had. And you see that we get our actor, our movies, our actor, our movies, and our actor and our movies. So that's a way to kind of use something called structured output to get a type bet. So again, this is one of those things that I said, hey, when we start working in the real world, sure, we can call REST API on GPT or on OpenAI's GPT, but these are some of the problems that we would have to solve for. And I don't know about you, but serializing and deserializing JSON is not something I want to work on. So, okay. Last thing I want to talk about, structured output, or oh, sorry, wrong one. Bring your own data. So we want to be able to use our own data in these AI applications. How do we take advantage of it? We know that models have limitations, right? They're trained with public knowledge up to a certain date. I think GPT-4 was September of 2021. So anything after that, it doesn't really know about. So if we asked it a question about the Olympics, I have an example of that. It's not really going to know about that because it wasn't trained on that data yet. They also don't know about your private data, your corporate data, if you want to be able to answer questions on that. So what can we do about this problem? Well, we have a few options here. We can fine tune the model. This is something that is possible. It's a little bit more complex. Nothing I have done before, but there is an option to fine tune models. There are also another way to do this, kind of adding context to your request. Sometimes you'll hear this referred to as like stuffing the prompt, being able to add your data to the prompt. We'll see an example of this. And then there's this thing called functions or tools in other contexts, which is a way to make real-time data calls. So there's something you hear about a lot called retrieval augmented generation, similar to stuffing the prompt. How to retrieve relevant data that the user inputs and add it to your prompt. So we have a bunch of strategies that we can do to kind of bring our own data. So I want to take a look at the stuffing the prompt example. As I mentioned, maybe I asked a question, what sports are being included in the 2024 Summer Olympics? Again, GPT-404 was trained up until September of 2021. It's not going to know the answer. Now, it may try and make one answer up. You might have heard of like hallucinations before. It's just going to kind of make up an answer. In this one, I'm saying, hey, if you don't know the answer to that, don't answer it. Just say, I don't know. So if we ask this question, it's basically going to say, I don't know the answer to this. But if we stuff the prompt and add some context to it and give it the list of sports that are in there, then it can go ahead and answer it correctly. So we're adding some context to this. Similarly, there's something called retrieval augmented generation. Now I did an example of this on my YouTube channel, and this is where this really kind of comes into play. So the Spring Boot reference documentation, if you go out there, you can download a single PDF. It's like 1,000 pages. Now that we understand that there are these things called tokens and that this costs money, it doesn't make a lot of sense for me to send 1,000 pages of context every single time I ask the LLM a question, right? That's not very cost effective. And quite frankly, if you ever hear that some of the LLMs, all the LLMs have a context window, a max context window, like you can only send so much context every time. So that's not going to work. So how do I get it to know about the information in my 1,000-page PDF? Well, what happens is we take this PDF, we split it up into documents. We use something called an embedding that is able to take those documents, the information from those documents, and store it in a vector database. Now, what's stored in a vector database is a vector. And these are kind of mathematical computations, and we have ways to kind of look those up quickly. But what that allows us to do then is when we ask something of the LM, before we go off and send that request out, we can do a quick similarity search in a vector store and pull out the relevant bits. So no longer are we sending a 1,000-page PDF, we're just sending the bits that are kind of relevant to that. So again, we're stuffing the prompt, we're augmenting the prompt before we go ahead and communicate with the LM. So there are a lot of vector stores that are supported out of the box in Spring AI. You can look at the documentation to find that out. There's a simple vector store there too, which is great because it's just like a JSON file. It's a nice simple implementation of a persistent vector store, really great for educational purposes. And that's the one that I have in this repo. And then there's function calling. I'll show you an example of that because we are running out of time. So we talked about stuffing the prompt. We talked about RAG, so retrieval augmented generation. We have this Olympic FAQ. It has a bunch of question and answers about the 2024 Olympics. Again, if we didn't have this document, if we asked how many athletes were competing in the 2024 Summer Olympics, they wouldn't know the answer to it. But we can kind of add some context to this, but we don't want to send the whole context, right? So we store this in a vector store. There are lots of examples of how to do this out there with your own documents, text documents, PDF, Excel, whatever. We can store it in there. And we split this up and we store these embeddings in a vector store. So we only do this once. Like, we're not doing this over every single time. We're just kind of loading the database the same way you would a regular database, right? Then we have this FAQ controller, and we have this question, and we say, how many athletes competed in the Olympic Games in Paris in 2024? None of this looks any different, right? But this looks a little different. We have this thing called an advisor, and one of the advisors we have is a question and answer advisor. And so this takes a vector store. And now, because of that, it will be able to kind of do everything on the back end that does the similarity search on the vector store and send that along as context when we ask a question. So if we go back to our terminal and we say, what is this, /FAQ. So if we say localhost 8080 /FAQ, it should be able to answer that. It says the Olympic Games will feature around 10,500 athletes from 206 national Olympic committees. So that's an example of that. One other example I want to show is function calling. So I have this city controller. And if I were to ask it a question like, what is, actually, let's do that now. Let's say HTTP 8080 cities. What is the message? What is the largest city in Ohio? Right. All right. It's going to come back and it's going to say the largest city in Ohio by population is Columbus. Now, what if I asked, what is the current weather in Columbus? Well, by default, it's going to go, I don't know. I don't have information to real-time data. Similarly, what if you asked, like, how many of our customers, or let's say I had a newsletter. So I have this newsletter and I said, how many subscribers have opened the current newsletter? Like, I wouldn't know that, right? But we can write custom functions to get access to real-time data, like the current weather. And the way that we do this is here we're saying here's a default function. The name of that function is just the name of a bean. And we've defined this function here. So we have this function. And now what happens is when we ask GPT something like, hey, what is the current weather? It goes, I don't know, but I do see you have a function that can probably get access to that data. It passes it back. We call the function. We send that information along as context back to the LLM. And again, I've seen this implemented in other languages like JavaScript. There is a whole song and dance to make this happen. This really just happens underneath the hood with Spring AI. You don't have to worry about that. At the end of the day, it's just a weather service. This is just using a REST client to talk to a public API and get that information about the weather. So if I go back here and now I say, what is the current weather in Pittsburgh? Current weather in Pittsburgh, Pennsylvania is sunny with a temperature of 80.1 Fahrenheit. The wind is blowing, the humidity is at 42%. So again, that's kind of giving us access to real-time data. The last one I'll kind of point out is this memory. So this is another advisor that we have. So we looked at the question and answer advisor that can use a vector store. Something we forget, the web is kind of stateless, right? It doesn't remember things. So if you were to ask GPT, if you were to tell GPT, hey, my name is Dan, and then send another subsequent request and say, what is my name? It's gonna say, I don't know your name. And we forget this because we use products like ChatGPT. If you do that on ChatGPT, it will remember that. So we need to remember the distinction between the product that is ChatGPT and the LLM that is GPT. But Spring AI has a way to kind of provide conversational history. Again, we're kind of sending context as we go. So we want to make sure we're not like saving too much context and sending that off. But in that example, I can take in we can set an advisor here called an in-memory chat memory advisor. And again, what that allows me to do is say 8080/chat, and I can send a message. And I could say, my name is Dan. And it's going to say, all right, nice to meet you, Dan. How can I help you? Now I can go ahead and say, what is my name? And it will say, your name is Dan. But again, if we didn't use that kind of in-memory chat memory advisor that Spring AI gives us, then it wouldn't have that conversational history passed in the context. So I know that's a lot being thrown at you. That's because we can do a lot. I'll give you some references. The Spring AI reference documentation is great. Really the best place to get started. Talks about all the different LLMs that were supported, all the vector stores that are supported, examples of how to do all this stuff. We didn't get to look at like image or speech. There's some examples of that in there. There's a really good Google course out there on Cloud Skills Boost that talks about some of the generic terms that we talked about, really just AI in general. And then the Spring team, Dr. Mark Pollock, Christian Tozoloff, they did a presentation at Spring IO that you can watch on YouTube if you're interested in watching that. My coworker, Craig Walls, is writing a book on Spring AI that I'm lucky enough to be a reviewer on. So I'm excited about that. And then the great Josh Long has a ton of content out there on Spring AI. So that's me. Dan.vega@broadcom.com, at the real Dan Vega on the Bird app. You can find more about me at danvega.dev. And with that, I'd love to answer any questions you have.
Wait, I don't see any on the chat, but if folks want to ask any questions, like either drop a note in the chat and I can read it out for you, or raise your hand maybe. Okay,
I do
there's
see a
actually,
question there. Yeah, from
go for it.
Walter. Yeah, so what does Python do differently than Java? And again, it's more about a lot of the tools in that space for building up a lot of these LMs, these training sets, that's just been doing it a lot longer than any other language. So if you're building up an LM, there's a lot of tools and resources in that space to do it. Doesn't mean you can't do it in Java. There's just more of a community there doing it. But again, I think we're kind of making that distinction now. Building these large language models and consuming these large language models are two different things. And as far as what I care about, what I want to take advantage of, I can do that in Java. I could do it in any programming language.
Okay. Philip has a question for you.
Does Spring AI provide a way to take the LLM responses, create embedding representing the LLM prompt and response, and then store it in a local vector store? Take the LLM responses. So you're not creating embeddings from the LLM. So the vector store is really a way to store your information, right? You want to store that in a vector store because, like, take the example that I talked about. I have this 1,000-page PDF. I don't want to send 1,000 pages, but I want to be able to quickly find relevant information about the question that we're asking. So in the Spring Boot reference, what is a REST client? It the reason we store it as a vector is because it can do super fast similarity searches and pull out relevant context about that. So it's not just doing like a text search on a string, right? It's doing a similarity search and pulling out the relevant bits that we can then send along in the request. I'm not sure we don't want to take the response and store that in a vector store. If you were just like storing responses, you could store that in say like a normal DB somewhere. What is Dave and Andy's? Is that a sub shop?
It's an ice cream place. I'm fairly sure.
Ice cream. Oh, even better. I'm gonna have to go there.
Cool. I mean, oh, wait, we have one more question. That's great.
All right. Could you talk about the security aspect? Would assume businesses are hesitant of how the AI is embedded. Yes, hopefully the question makes sense. Yeah, for sure. So one of the things we're doing here is we're talking about OpenAI, right? And like, do we really want to send all of our private information off to one of these big data companies? So there are other options out there. If you go back to let me go back here, go back to the Spring documentation. And if you look at the Spring API, we have some different chat model APIs. One of these is something called Olama. With Olama, you can run various large language models locally and generate text from them. So no longer am I sending something out to some big data company. I can run different models right on a machine without being able to send that out. So that's definitely an option. And a lot of people, yeah, obviously, a lot of people have that same concern. So that's something you could do. Is there a book or a course that you'd recommend? No, there's nothing yet. So, well, there is Spring Academy, which is now free. So Spring Academy is completely free if you weren't aware of that. We used to have a paid version that gave you a coupon for a certification. Now the certification you just have to pay for, but Spring Academy is completely free. And there is a course on Spring AI, I believe, in here that Craig worked on. Let's see, Spring AI. Maybe it's a guide. There we go. So yeah, there is something that kind of walks you through it. What I like about the Spring Academy is you can do it right in the browser. So as you're like reading, you can like type into like a text editor. There's like a platform behind here that does that. Outside of that, again, Craig Walls, the instructor on this particular guide, is writing a book that's not out yet. So no, we haven't even hit 1.0 GA yet. We're still at milestone 1. Milestone 2 is coming up. I kind of know when GA is supposed to come out, but I can't really say. But it should be this year. So I can say that, I think, with confidence. So yeah, we're, a biggest thing with especially Spring AI and AI in general, it's just changing very rapidly right now. And part of the milestone 1 release of Spring AI was to really kind of stabilize the API. It's been in fluctuations, changed based on customer feedback. And I think what we've really done, stabilize the API. Let's march towards 1.0 and then kind of move forward from there.
Yeah. Also, Dave and Andy's is closed apparently. So Dan, don't go looking for it.
Oh, no.
Okay, we'll find you a better ice cream spot here.
Well, if you guys are up
Suresh,
here,
fighting words.
I don't know. I actually rely on like some of them to help me out as well. So anyway, Dan, thank you so much for joining our jug. Really, it was a very different topic, but also a topic that everyone's like hearing about. So thank you so much. I guess, yeah, Istvan, thank you for helping us connect with Dan on this and bringing in a speaker like Dan to our jug. That's pretty much. Yeah.
I just want to say thank you. Thank you guys for having me. It was, yeah, I love geeking out about this stuff. So I appreciate you giving me an hour to ramble on about it. And like I said, if you guys get back in person, I definitely need to make it up to Pittsburgh. And I don't mind coming in January because we have the same weather.
Okay, yeah, that's right. Yeah, that's right. Yeah, no, that's definitely like, yeah, you are definitely will be the first person that will be knocking on your door for sure as soon as
Awesome.
we go in person. Yeah. Thank you
Cool.
so much, everyone, for attending the Pittsburgh Jug event as well. Again, keep an eye out on our meetup page to see what our upcoming events look like. That's
Yep.
it.
Cool.
Have a great Thursday and a weekend.
Thank you, everyone.
Thanks,
and the
everyone. Have a good
video
one.
will be up in the
Bye-bye.
next few days.
Oh, yeah. Yeah. The recording will be up too. Yeah. Bye-bye.
Bye.
Bye. Bye.